XMPP for Instant Messenger. XMPP is a communication protocol based on XML for nearly real-time instant messaging. Its original name is Jabber. This border controller is with XMPP server running so that XMPP client can be used for instant messaging application. XMPP also allows server-to-server communication so that you can use it to communication with other XMPP servers. For business use, you can use the company's messenger ID to invite business partners, for example. And the server can have a copy of chat log as the reference for online meeting minutes. The server can be turned on via System Management XMPP user control. The host name shall be set as fully qualified host name for internet servers or domain name with the corresponding XMPP SRV records. Otherwise, the XMPP client shall be using IP address to connect to the server. The user accounts for XMPP shall be created via the Total User Management Interface add system users add user or system user users. When XMPP server is running, it uses TCP port 5222 for client communication and TCP port 5269 for server-to-server communication. For two XMPP clients to send messages to each other, they have to accept the invitation from the other party so that it reduces the chances for being spammed. The server itself can also block the communication with the other servers. This can be done via a system user S2S policy or the setting of blacklist border connection update blocked host of border control. There are multiple XMPP clients, like Pigeon, Jujitsu, or Beam, that can be used on desktop computers or mobile devices. Some of the XMPP clients provide desktop sharing or video conferencing. We would like to emphasize that those features like desktop sharing, file transfer, voice or video are just using XMPP as signaling channel. Its implementation is nothing to do with the server. So, those features might work in peer-to-peer manner but fail when both of the clients are behind different firewalls. Fault-tolerant configuration. If the Ethernet ports of your machine are labeled bypass by pairs, it behaves as follows. When the machine is powered down, the pair of bypass Ethernet ports are connected such that the traffic from one port can go to another like an Ethernet hub. When the machine is up and running, those labeled bypass pairs are functioning as separate Ethernet interfaces if the bypass LED indicator is not on. This trick of hardware design cannot function well alone, it needs to team up with the other device. Assume the application of the machine does not accumulate users' data. The function of the machine can be purely determined by the software configuration parameters. We can use two machines connected in the way indicated in the following diagram to achieve fault tolerant. If the machine on the left is powered down, the traffic will be flowing to the machine of the right. This is particularly useful when the machine is used for load balancing. Border rule IP load balance. The real servers are sitting behind so that the load balancer itself does not contain data. Thus, at the position of load balancing, we use the configuration above to enhance the stability of the whole system. We use the following diagram as a specific example. Machine A is with 6 Ethernet ports and machine B is with exactly the same configuration. The Ethernet ports ETH0 and ETH1 are bypass pair on machine A, ETH2 and ETH3 behave in the same way. Please note that bypass function is only working when the machine is powered down or triggered by software. In the condition of normal usage, they are just Ethernet interfaces belonging to their specific subnetworks. On machine A, ETH0 is functioning as WAN port to connect to the internet, ETH3 is connecting to office LAN. The network traffic from the subnet connecting to ETH3 with destination to the internet will be operated via NAT, network address translation, and go out via ETH0 by using the IP address of ETH0 as source address while going out to the internet. On machine A, the Ethernet ports ETH1 and ETH2 are set to off state. ETH1 on machine A is connecting to ETH0 of machine B, and ETH2 on machine A is connecting to ETH3 on machine B. Since ETH0 and ETH2 on machine A are on off state, machine A and machine B cannot affect to each other even if they are with the same IP address setting. When machine A is powered off or triggered by software to enter network bypass state, the bypass pairs will be functioning so that the machine B will handle the traffic originally destined for machine A. It is working in the sense that network packets to ETH0 of machine A will be processed by ETH0 of machine B because ETH0 and ETH1 of machine A are bypassed when the machine A is powered off. Network packets to ETH3 of machine A will be processed by ETH3 of machine B because ETH2 and ETH3 of machine A are bypassed. From the description above, you will notice that machine B does not need bypass pairs. Bypass pairs are only needed on machine A. Thus, as long as you can have another machine behaving in the same way, you can mix machine A with the machine provided by the other vendors. In the setting mentioned above, the Ethernet ports ETH1 and ETH2 are set to off state. This can be done via system network Ethernet status. The network speed is set via auto negotiation. The field link detected is to display the status if the link is wired properly and active or not.